Hi everyone, Dr. Vaughn, and I'm going to make a quick video for you. This is on section 7.2, applying the law of sines. We're looking at the homework. Here's question 1. Which of the following sets of data does not uniquely determine a triangle? So you have these 4 different kinds of things. In each one of these, you have an angle, you have the opposite side length, and then you have another side length. So you have 2 sides and an angle. And one of these sides goes with one of the angles. So this is a side-side angle kind of approach. In general, side-side angle is not enough to uniquely determine a triangle, but there are rules that go with it. And I would just suggest if you go to the question help and go to the textbook, it'll open up the exact page in your book that has the table that gives you the outcomes for applying the law of sine. So I have it pulled up over here. All right, so we're going to look at the angle A and then classify it as being acute, and then look at the relationship between the other sides, and then use this table to make a determination. So up here in part 1, we have the angle A is 30 degrees. We have little a is 4, and little b is 8. So in this particular case, if you put in this the sine of b, so you calculate the sine of b using the law of sine. So you take the sine of a over a, or little a over the sine of a. It doesn't matter which one you put on top as long as you do it consistently. So let's put little a 4 over the sine of 30 degrees, which is 1/2. So 4 over 1/2 equals 8. And this would be 8 then on the other side over sine of b. So sine of b would have to equal 1 if you do out the math, which means that b has to be a 90-degree angle. So this is exactly that case up here in part A, where the sine of b turns out to equal 1, and you have a right triangle. And there's only one possible right triangle that this could be. So this does uniquely determine a triangle. In the second case, you have an acute angle, 45 degrees, and you have A is bigger than B. So we're going to go over here to the acute cases, these top 4 kind of cases, and look for A is being bigger than or equal to B. So we're in this case right here. And in this case, the sine of B, you can work it out, turns out to be it's about 0.58 or so. And the angle B actually turns out to be very close to 45, well, it's 36 degrees. But anyway, we're in this case right here, and you can see according to the table, there's only one possible triangle that can satisfy these conditions. So part B is enough to uniquely determine a triangle as well. In case C, we have an obtuse angle. A is 130 degrees, and again, we have this A is bigger than B. So we're going to go to the obtuse cases, these bottom 2 cases, and look for A is bigger than B. And again, you're right here in this case, which again has a unique solution. In the bottom case here, you have the angle A is 50 degrees. That's an acute angle. And now you have B is greater than A. So this is the one that puts us into this case right here. Now, if you compute the sine of beta 1 by using the law of sines, you do get an angle that's in between 0 and 1. And when you take the inverse of that angle, there is another angle that corresponds to it on the other side. One of them acute, B1, and the other one obtuse, B2. And so there are 2 possible triangles that can be selected in this particular case. So we'll select that radial button and check our answer. And yes, okay, excellent. We're on to the next question. So if we go to the next question, I think it's a pretty similar kind of thing. The only thing in this case is that not all of these have 2 sides and an angle, or 2 angles and a side. So in this case, you have side, side, side. Now, if you can build a triangle out of these 3 things, then it must be unique. However, the sum of any 2 sides of a triangle have to be greater than the 3rd side. So in this case, you have A is 3 and B is 5, and 3 plus 5 is only 8, which is not bigger than 20. So you can't take a shorter distance by going 2 sides of a triangle than the one distance, which is the side of a triangle. So this is not possible to build a triangle with these dimensions, because the sum of 2 sides is not bigger than the 3rd side. So that one doesn't determine a unique triangle. Here we're just looking at the angles 50, 50, and 80. So 50 plus 50 is 100, and 80 degrees is 180. That is enough to determine a triangle. However, this triangle can be scaled to lots of different sizes. So that uniquely determines the angles of the triangle, but not the size of the triangle. There are lots of triangles. They're all similar to each other, but they're not congruent to one another. They don't have exactly the same dimensions. Here we have three different lengths. Again, 7, 24, 25. In this case, when I add 7 and 24, it is bigger than 25. When I add 24 and 25, it is bigger than 7. And when I add 7 and 25, it is bigger than 24. So this is a case of a triangle that can actually be constructed with all three of those dimensions. Since it can be constructed side, side, side is enough to uniquely determine the triangle. So this is going to be the one that determines a unique triangle. Just for the sake of completeness, we'll look at this bottom option. Here you have 40, 20, and 30. So the sum of the angles here is only 60 plus 30 is 90. You only have 90 degrees worth of angles. So this is not going to be closing up to make a triangle because you have to have 180 degrees total to make a triangle. So this is not good enough. All right, so C is the only one that's going to work here. All right, let's just kind of flip through a couple of the other questions that you have on here. This is determine the number of triangles ABC with possible given pairs. So I think that this would be a question of just applying these rules yet again. It's just in a certain case. Don't get caught up on the A and B. In this case, you have capital B and little b and then little c. So once again, you have two sides and an angle. So you can still apply these rules. You're just going to transpose the rules of A and B to get through this one. Again, this is pretty much the same thing. We've got several of these that are applying these. All right, now we have this side angle. And you want to find the angle B over here. This should be a fairly straightforward application of the law of sines. That in this case, they've drawn for us an acute triangle. You take the sine of 60 over 4 root of 6 equals the sine of B over 8, and then solve for the sine of B, and then use the inverse sine to actually find the degree measure. Make sure your calculator's in degree mode in order to do that. So that's the straightforward application. I think most of these questions this week are going to be that sort of thing, direct applications of the law of sines. All right, so that's a very brief video. I know we didn't do very many problems, but hopefully it gives you a good introduction into getting started on the law of sines. Make sure that you use the feature up here to link forward to the textbook if you want to see. Look at an example. Also try to help me solve this if you get stuck on any of those. And also don't be afraid to use the Ask My Instructor. I haven't gotten very many of these from you this semester, but feel free to click this button. It'll shoot a copy of the problem to me, and then I can get back to you in email with any help if you're stuck on any kind of a problem along the way. All right, well, I hope you're all doing well, and keep up the good work, and I hope to talk to you again soon. Talk to you later.